All right, now we have a question about Peruvian sweatpants, we'll say. The number of Peruvian sweatpants being made is anywhere from 2 to 7, and the associated probabilities are listed below. And the first question we're asked is, what's the expected number of Peruvian sweatpants we make? All right, well, that's an easy enough calculation. We're going to use expected value of x. Expected value of x is a formula that just says you're going to sum up all the xi times pi's. I know it seems like a scary formula, but all that means you do is you take these two numbers and multiply them, take these two numbers and multiply them, take these two numbers and multiply them, all the way down, and then add the result. That is, we're going to take 2 times 0.1 and add 3 times 0.1, 4 times 0.2, and so on down the line until we get down to 7 times 0.1. And when we get that, we get 4.7. Easy enough calculation, right? Variance is a little bit harder. Variance says you need to find e of x squared, whatever that means, minus e of x squared. I think I just said the same thing, but careful. This x is being squared where e of x is being squared here. And what that means is, hell, we already have this guy. This 4.7, we already found. E of x was what we found a second ago, so that's already done. The e of x squared part is the tricky one. What we need to do is we need to do the same exact calculation we did before, but with the squares of these values. So what we'll do is we can make a whole brand new table, or we can just fix this table. We're going to square each of these x values up here. So instead of saying 2, 3, 4, 5, 6, and 7, we're going to say the squares of those values. Or we're going to say 4, 9, 16, 25, 36, and 49. When I do this, let's do this over here. E of x squared, I do the same thing. 4 times 0.1 plus 9 times 0.1 plus dot 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 all the way down to 49 times 0.1. And when I do that, I get 24.1. Okay, not 24.1, careful, that's not our variance, that's just merely e of x squared. So we need to take this value, this 24.1, and put it here. We get 24.1 minus 4.7 squared, and that'll give us 2.01. So this is our expected value, this is our variance. Now we're going to move on to trying to figure out the profit that we make by selling these Peruvian sweatpants. Let's do this over here. So we're told that we make $12 for every pair of Peruvian sweatpants we sell, but we lose $2 in terms of the goods that we use to make it. So that's a net $10. We get $10 per pair of sweatpants we make, but we lose $3 no matter what we do. So in terms of income, we'll say income instead of profit. It's probably a bad idea to use P as a variable since we use it for probability. Income is equal to 10x, right? We gain $12 but lose 2 for every pair that we make, minus 3 no matter what. So this is our profit. Income or profit equals 10 times x minus 3. You might then be asked to find the expected income or expected profit. That's easy enough. I keep saying it's easy, but it is. What we're going to do is we're going to take the expected value of both sides. Taking the expected value of both sides might seem scary at first, but when you take the expected value of an equation, it's just like taking the square root of an equation. If I asked you to take the square root of this guy, you'd say square root of this and square root of that and be done with it, right? Expected value is the same way. Expected value, you do e of I equals e of 10x minus 3. Now, you got to know the rules of the expected value. You're allowed to split this expected value. That is to say, I can say e of 10x plus e of negative 3. That's a rule you're allowed to use when you do expected value. Splitting this expected value is something you can always do. Furthermore, we're going to do 2 rules in one step here. This 10 as a coefficient of the x can come out in front of the e. So we have 10 times expected value of x plus the next rule we're going to use is that expected value of a constant is just that constant. So expected value of negative 3 is negative 3. A moment ago, we found e of x. We found e of x to be 4.7, so we have 10 times 4.7 minus 3 ends up being 44. So this is the expected value of the profits we get from selling these Peruvian sweatpants. We also need to find the variance. I'm going to make some room over here. The variance calculation is done in a similar way. So given the formula for the income, which is I equals 10x minus 3, we're going to take the variance of both sides. So I'm going to say v of I equals v of 10x minus 3. Once again, we can split any sort of 10x minus 3 into variance of 10x plus variance of negative 3. There's two rules that happen here the same way that they happen for e of x. When we pull a 10 out through the variance, the same way we pull a 10 out through the expected value, you have to square that coefficient. So 10, when pulled out, becomes 100, variance of x. And the variance of a constant is 0. So we just have 10 times variance of x. The variance of x we found a moment ago to be 2.01, so 2.01 times 100 will end up being 201, and that is our answer there. It's as simple as that. So make sure you know these formulas about variance and expected value and how they operate, especially when you take the expected value of some linear combination of x's and some constants, and as well for variance. And other than that, there's not much else to say, so see you later.